Hello and welcome everyone. Thank you for joining the fourth session of GOA-ON's Ocean Acidification Week 2020, a virtual multi-day forum to highlight different aspects of ocean acidification research and initiatives. OA Week is presented by GOA-ON, the Global Ocean Acidification Observing Network, by NOAA, the National Oceanic and Atmospheric Administration, by the IAEA OAICC, the International Atomic Energy Agency, Ocean Acidification International Coordination Center, and by the IOC-UNESCO, the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific, and Cultural Organization. This session will feature talks from around the Arctic polar region. We were glad to see that over 150 people pre-registered for this session, and right now we have about a third of those individuals present. We hope the rest join over the next few minutes. My name is Michael Aquafreda, and I work with the GOA-ON Secretariat. I'm also a Knaus Fellow working at the NOAA Ocean Acidification Program. I'll be moderating today's session. During the presentation, all participants are in listen-only mode. You are welcome to type any questions into the questions box, which can be found at the bottom of the control panel on the right-hand side of your screen. You can also post questions on Twitter using the hashtag OAWeek2020. Make sure to call out which speaker you're directing your questions to. We'll be monitoring incoming questions and will pose them to our speakers during the question and answer section, which will begin immediately after the last presentation. Today's webinar is being recorded and will be available through the GOA-ON YouTube channel soon after OA Week ends. Before we hear from our speakers, I would like to share a short presentation about GOA-ON. GOA-ON is a collaborative international network designed to address three high-level goals. First, to improve our understanding of global ocean acidification conditions. Second, to improve our understanding of ecosystem response to OA. And third, to acquire and exchange data and knowledge necessary to optimize modeling for OA and its impacts. GOA-ON is an active organization that offers numerous resources to its members. GOA-ON interacts at the international policy level. GOA-ON is an active part of the UN Decade of Ocean Science for Sustainable Development 2021 to 2030, and has also been involved with the Commonwealth Blue Charter. More specifically, GOA-ON members assisted with the development of the SDG Indicator 14.3.1 methodology and provided guidance on how to measure ocean acidity and how to report the collected information. This supports the UN Sustainable Development Goal 14 to build towards a 2030 sustainability agenda. GOA-ON also offers a peer mentorship program called the Peer-to-Peer Network. Peer-to-Peer's scientific mentorship program matches senior researchers with early career scientists to facilitate an exchange of expertise and to provide a platform for international collaborations. Scholarships and hands-on trainings are also available through the Peer-to-Peer mentorship program. GOA-ON also offers an online data portal that provides access and visualization to ocean acidification data and data synthesis products being collected around the world. These data come from a variety of sources, including moorings, research cruises, and fixed time series stations. Most recently, GOA-ON began a webinar series, and Ocean Acidification Week represents the first sessions of this webinar series. We welcome your input on future topics you would like to hear about in future GOA-ON webinars, which will occur every 4 to 6 weeks going forward. If you have any ideas, please type them into the questions box and we will take them into consideration as we make our future plans. GOA-ON has 8 regional hubs, and we'll be hearing from most of those hubs throughout Ocean Acidification Week. Overall, GOA-ON has over 750 members from over 100 countries. If you're interested in joining GOA-ON, please visit the GOA-ON website, goon.org, and become a member today. One of the reasons why GOA-ON decided to host Ocean Acidification Week was because initially the 5th International Symposium on the Ocean in a High CO2 World was scheduled to take place this week in Lima, Peru. Yet, like many other events scheduled for this year, the symposium had to be postponed until 2021 because of the COVID-19 pandemic. This symposium would have brought together researchers, decision makers, and other stakeholders to share cutting-edge OA science. We're looking forward to that and hope everyone listening today will visit the symposium's website and learn more. See you in Peru in September 2021. I'm glad to present the speakers for today's session. They are coming from all across the Arctic polar region. They include Agneta Fransson from Norway, Melissa Chierici from Norway as well, Eric Mortensen from Australia, Andrea Niemi from Canada, and Wei-Jun Kai from the United States. At this time in the presentation, I usually give a little bit of information about the Arctic hub, about the hub that is presenting. But today, our first speaker will discuss in detail the newest GOA-ON regional hub, the Arctic hub. So without any further ado, I'd like to introduce our first presenter, Dr. Agneta Fransson. Agneta, I am now making you the presenter, and you could begin whenever you're ready.
Okay, welcome to the GOA-ON Arctic session and introduction and kickoff of the Arctic hub. I'm Agneta Fransson, and I lead the hub together with Melissa Chierici, Kumiko-Azetsu and Jessica Cross. And we had the intention early this year in March. We were supposed to have the start of the Arctic hub in Tokyo at the ESAR conference, but unfortunately this was cancelled due to the COVID-19. So now we make another try, and we hope we have success this time. So I'll try to change slide here. Now, yeah. When I saw this Ocean Acidification Week program and the map, I immediately found that something was missing on the map. And of course, it was the Arctic Ocean. And then I went into the GOA-ON data portal of the Arctic Ocean region, and I found some more information with some data and observations in the Arctic. But it's still lots of data and observations missing. So the Arctic hub will fill these data gaps. And we welcome everyone that have data observations to join as a member and add information in this data portal. And that helps for everyone interested to have a look what's there, and also start to initiate some collaboration between groups and countries. So what is special about the Arctic Ocean compared to other oceans? Arctic Ocean has gateways to both the Atlantic and the Pacific Oceans. And you have the inflow of Atlantic water in the Fram Strait into the Arctic, and also inflow of Pacific water in the Bering Strait. And these water masses mixes with fresh water from rivers and sea ice melt, and you have a lot of different water masses. And you have, as I mentioned, lots of rivers, which also add organic matter and carbon to the ocean. And you also have permafrost and of course sea ice. And there are large shelf areas and deep oceans. And this hub is connected to the other hubs, so there will be some overlaps and collaboration between the hubs as well, I hope. So sea ice is important in the Arctic Ocean, and sea ice acts as a habitat, both on the ice surface, but also under the ice, and as well as in the ice. So there are sea ice biochemical processes in the ice that affects gas exchange and CO2 interaction between the ocean and also to the atmosphere. So with changing sea ice from multi-year thicker ice to first-year thinner ice, this will of course change the habitats and the processes, and there will also be more meltwater and more open areas in summer especially. And this we have observed effects on sea ice melt and glacier meltwater on ocean acidification in the Arctic Ocean and in Svalbard and Greenland fjords. And this is from Kongsfjorden, which is in Svalbard, and where we have seen effects of glacier meltwater and sea ice meltwater on ocean acidification, and also on the CO2 uptake. We have found that the aragonite saturation decreased with increased fractions of fresh water. So that have, of course, implications for aragonite forming organisms in the areas. And we have phytoplankton production with CO2 consumption, which counteract part of this effect of meltwater. And there are these special processes in the Arctic Ocean, and that makes the Arctic Ocean also vulnerable to climate change, such as warming, less sea ice and more open water. And you will have also increased fresh water as the meltwater, and increased river runoff, which also add carbon into the ocean and affects the stratification as well, surface stratification. And it's already observed low calcium carbonate ion concentrations and aragonite saturations on the freshwater influenced shelves, and also spreading and shoaling of the low aragonite saturation in the Arctic Ocean. So there are also observations on changing potential for ocean CO2 uptake in the Arctic as well, and some effects of permafrost thawing on ocean acidification with the release of CO2 and methane to the ocean. So all these changes, of course, have some effects on the marine organisms, especially the organisms that form calcium carbonate shells, and for example, pteropods. And there are also some modeling efforts on ocean acidification effects on sea ice, so you get some regional insights into regional processes and learn more about how sea ice and other processes in the Arctic affect the ocean acidification. So some of these of these issues you will hear more about during this Arctic session. And we have some ongoing activities in the Arctic Ocean to fill data gaps. And there is a mosaic campaign going on right now in the Arctic with the Polarstern frozen in and drift with the sea ice for 1 year. And it's led by Germany. And we also have the Nansen Legacy. It's a Norwegian project led by Norway and in the Northern Barents Sea and Nansen Basin, where we study seasonal variability. And the Canadians are doing lots of monitoring at various sites in the Arctic, including Davis Strait, Baffin Bay, Beaufort Sea, Canadian Archipelago, and the Hudson Bay system. They also develop a long-term high temporal resolution monitoring program at Tuktoyaktuk in Canada, using GOA-ON in box, where you can measure pH and you can involve community and local people. There is also something called the Shell Day, which was a US program in the Northeast Coastal Acidification Network, and also involve community to collect alkalinity and salinity and temperature to get awareness of the ocean acidification in the general public. And that could be something to develop as a pan-Arctic Shell Day. That's something we can discuss in the Arctic Hub, to be something that could be interesting to have this, circumpolar knowledge. And there's a development of the sail drone of ocean acidification research in the Arctic, led by US. And we have the Synoptic Arctic Survey in 2020 to 2021, which includes several countries like Japan, China, South Korea, USA, Canada, UK, Sweden, Norway, and also other countries as well. And to get this Pan-Arctic understanding. So there will be focus, some part of it will be carbon uptake and ocean acidification. So there is a need for more observations, a time series on seasonal and interannual focus, and to find trends. So we need longer time series. So that's, we have to help each other to work on that. So this is one, as I said, the Synoptic Arctic Synoptic Survey, which is one suggestion to have this Pan-Arctic survey. And the countries they have research, they will contribute with data using research vessels and operate in different areas of the Arctic Ocean. So if you have data or initiatives to report or suggestions on common activities, just send an email to me or any other in the Arctic Hub or to GOA-ON. And if you want to become a member in the Arctic Hub, you can also contact me or anyone else in the hub, and you could also go into the GOA-ON website. So I hope we can work together, and next time we will meet perhaps in Lima or some other meeting, hopefully next year. So I think it's a good way to start, and with this GOA-ON week, and I hope everyone that wants to be involved and have interest in the Arctic, you are welcome and sign up. Thanks for your attention.
Thank you very much, Agneta. I'd like to introduce our next speaker now, Melissa. I am now making you the presenter.
Can you see it?
Yes, we can. Just go ahead and make it full screen for us.
Yeah. So
that looks great.
I think. Yeah. Okay. So I'm Melissa Chierici, and as you can see from from this slide is that today I will talk about a multinational effort in the aim to get more ocean acidification observations in Norwegian and Arctic waters. And I will focus mainly on the Arctic today. And okay, I'll try, how do I do that? Now I'll try just to get the next slide. How do I do that?
Try clicking on the slide, and then using the arrows to progress forward.
Oh, okay, now, yes. Okay, sorry about that.
No problem, go ahead.
Fast. Yeah, no, so as Agneta showed, the Arctic is, even if there are more data points than in the GOA-ON map, there are still quite large data gaps in the Arctic. But since 2011, at least in Norway, we had a few programs initiated that really kicked off and increasing the amount of observations in the Arctic. And it was both effort from a national monitoring program, which started in 2011, which is mainly focusing on the Norwegian seas, but also includes the Barents Sea. These are the red dots here. This is not a comprehensive map, but it's a combination of water column observations on the repeat sections. It's surface water, both discrete and autonomous measurements. in the area, and also encompassing also the Greenland Sea and the Norwegian Sea. At the same time, the Fram Center in Tromsø started Ocean Acidification flagship program in 2011, where we focused on part of that flagship started more observations in the Arctic, more the central Arctic, north of Svalbard, around the Svalbard waters, and also a time series, initiating a time series in the Fram Strait, so between Svalbard and the northeast Greenland shelf, along 79 north, sorry. So we also have further south, we also have monthly coastal stations. There were also increased research activities. So several research cruises focused on the area north of Svalbard, because realizing that there were very few chemical and also physical and biological measurements there. That was also the case for the Barents Sea generally, where chemical and ocean acidification measurements were strongly lacking. This is also showing almost a decade-long surface water time series which NIVA is doing in this monitoring program between Tromsø and Svalbard, where we start to get quite a long time series. Although we cannot see a clear variability, we see large seasonal variability, but we cannot see a clear trend. From the PCO2, we can also see that we have a strong seasonal variability in the PCO2 as well. We also have started last year by adding sensors for pH and carbon dioxide and oxygen on several of the moorings, especially as part of the Nansen Legacy program, which are located then in the Barents Sea, trying to trace both the Arctic water and Atlantic water. Also, there is a PCO2 sensor in the Kongsfjorden, where we also have other measurements going on, and many institutes are working on monitoring the Kongsfjorden area, where we see strong climate change now. We are not only doing the chemistry, we are also combining as much as we can with biological sampling together with our chemical sampling. And this is just an example where we sample for foraminifera and pteropods, and then investigate the shell thickness. And we use the natural gradients of polar and Atlantic water to understand more on the shell and the living circumstances for these creatures. Some highlights from this Fram Strait time series. We were investigating more, in this case, the outflow waters, so the western part of the Fram Strait. And we can reveal changes, quite substantial pH decrease in the upper 50 meters, which is 6 times larger than the other open ocean stations, which has a longer time series. So this is a relatively short time series, but anyway, we can see this strong decrease. And we can also see that it's also the Arctic halocline, so where you have the temperature minimum layer between 50 and 150 meters. We also see a pH decrease there, which is also larger than the world ocean, the other ocean stations. We also see that the aragonite saturation decrease as we get closer to the northeast Greenland shelf, and that is where we also have the Greenland ice sheet, the melt water. From the NI study north of Svalbard, we also discovered that storm events made up these cracks in the ice, and where actually, even if the storms brought up some higher CO2 subsurface water and bringing up CO2 and nutrients to the surface, the surface water was still undersaturated. So during the storm events, when we had the cracks opening, we actually had quite a substantial ocean sink, even during winter, which was quite a new finding. We were also having some seasonal studies on the west of Svalbard, west and north of Svalbard, and we found that the spring we had a large CO2 uptake in this area, which was mainly governed by the high biological CO2 uptake during primary production. And in spring, this followed the meltwater signal. So if we have a change in the melt and sea ice melt, for example, then we might have a change in this biological CO2 uptake, which is also consequences for the general ocean CO2 sink. Kongsfjorden and Tempelfjorden has been really interesting studies. We have seasonal and annual cruises since 2011, together with this CO2 sensor. And they, since we have been there for so many years, now we get these contrasting years. So we can use these fjords as a climate labs. So we can see the influence, the role of the warm Atlantic water contra more local water, sea ice, hail and water from local sea ice production, as well as coastal Arctic water entering the fjords. One finding was that in some times of the year it saw a critical threshold for the pteropod in winter, especially in these fjords. If I go further south, this is part of the this is from the Skagerrak deep water, so much further south, more belongs to the North Atlantic hub. But since this also has relevance for what's entering the Arctic, it's interesting to look at what goes on further south, and also in the Norwegian Sea, where we see a large pH decrease in the Lofoten basin in particular, and we are not really sure why that is the case, and we are investigating that as well. Filippa Frassner will talk more about that. She has to talk tomorrow, presenting more on this part. We also had quite an interesting study looking at the diurnal variability. So over 24 or 26 hours, we did a very frequent measurements over a cold water coral reef of Norway. And we found that the diurnal variability of the reef was actually larger than the seasonal variability. And then we are not really sure how to handle it, but we realized that it's important information to understand more on the environment for the cold water coral reefs. If you want more data and more information, then I had some references on the slides, but I can also mention that there are annual reports in this monitoring ocean acidification in Norwegian waters, which you can find at this website. We have also published this data at the Norwegian Marine Data Center and Norwegian Polar Institute Data Center, and they will also be part of international carbon data centers. There's also this flagship Ocean Acidification Effects. You can also look at the Fram High North Research Center for Climate and Environment and find a little bit more information on the flagship activities there, which is much more than only the observations. And of course, the GOA-ON platform and activity information, but I also realized that I have some other platforms that we should add to this map, so we can start filling this map. Yeah, that was all. Thank you very much.
Thank you so much, Melissa. Our next presenter will be Andrea. We're going a little bit out of order today. So I'm going now to make Andrea the presenter. And once again, if any of the audience members has questions, they could type them into the questions box, or they could type them up on Twitter using the hashtag OAWeek2020. Just remember to call out which speaker you want the question directed to. Thanks. Andrea, we could see your presentation. Do you want to say a couple words?
Yes, thank you.
Yeah, we could hear you loud and clear. Take it away.
Okay, good day to everybody, and I really appreciate the opportunity to speak here about observed biological impacts of ocean acidification in the Canadian Arctic. And to, okay, I gotta just advance the slides. Start by thanking the co-authors for this work. And just a bit the talk, I'm just going to talk briefly about conditions in the study area and the rationale for our objectives. And then I'll present results relating to both the distribution and dissolution of pteropods, and then end briefly with some conclusions and future considerations. But to start, I would like to acknowledge that this research was conducted within the marine area of the Inuvialuit settlement region, which includes 6 Inuvialuit communities, which participate in the co-management of subsistence species and their habitats. And like other Arctic regions, the Inuvialuit settlement region, which is located in the Western Canadian Arctic, is facing a variety of stressors. And ocean acidification is another concern for the community members. The results I'll present today: ecosystem-based offshore programs, the Bria Marine Fishes Project, and the current Canadian Beaufort Sea Marine Ecosystem Assessment. And these programs have sampling stations indicated by the dots on the map on the Mackenzie Shelf and in the Amundsen Gulf. So about the study region, it's known that this area has relatively low aragonite saturation state for a variety of reasons, but a key factor is the inflow of undersaturated Pacific waters. There's not a lot of recent information on ocean acidification in the study area, and comprehensive biochemical monitoring is not really ongoing, although there is some research happening. Previous studies have shown that the aragonite saturation state is variable and has been declining over the last 20 years in both the Pacific water layer as well as deeper waters. And on an annual cycle, the Pacific halocline water can remain undersaturated for much of the year and can fluctuate seasonally for sure. And there has been recent increases in the occurrence of upwelling events, which of course displaces supersaturated surface waters with the undersaturated waters from the Pacific halocline. So the stage is set quite well for acidification effects in the study area. But to our knowledge, there was no previous investigations of biological responses in this specific environment. So we investigated the pelagic sea snail, Limacina helicina, which of course has been studied for years in different ocean environments as a sensitive biological indicator of acidification conditions. And our objectives were pretty straightforward. First, we wanted to assess the distribution of Limacina in different offshore habitats and in coastal embayments where zooplankton communities hadn't even been previously assessed, not just Limacina, but zooplankton themselves. And then second, we wanted to assess Limacina shell dissolution using scanning electron microscopy in years with different sea ice conditions. And our hypothesis was that if shell damage was going to be present, that it would be most severe around the areas of known upwelling. And this is the Cape Bathurst and Cape Parry area in the Amundsen Gulf. So for our distribution results, I'll just point out that in all years, sampling occurred between the first week of August and mid-September, and depth stratified samples were collected with a multi-net. So highest abundance occurred on the Mackenzie Shelf in 2012, and interannual variability was clearly evident. And in 2017, abundances from select stations in the Amundsen Gulf reached as high as 625 individuals per meter squared, with the majority of the individuals located between 50 and 200 meters depth. So in 2012 and 2017, it was clear that Limacina occurred within the Pacific halocline, and it's expected that they would migrate into those waters even if they congregate in the surface waters less than 50 meters deep, as observed for 2013 and 2014. In our study area, the shelf and Gulf abundances were quite high, but they could be much higher. For example, a study from earlier in 2005-06 found abundances over 10,000 individuals per meter squared. So this region where we were working could be described as a pteropod hotspot relative to other ocean regions. We assessed the dissolution. We did so for the Amundsen Gulf area only, and we considered 3 different habitats. We considered upwelling areas, including the Cape Bathurst and Cape Perry areas indicated in red. We considered small embayments indicated in green, and a gateway area, Dolphin and Union Strait, indicated in blue. And dissolution was assessed specifically in 2014 and 17, where sea ice opening at the Cape Bathurst area was about a month earlier in 2017 than in 2014. And during the sampling period, the euphotic zone integrated chlorophyll A concentration was on average 4 times higher in 2014 than in 2017. So the later ice opening and higher summer resources of 2014 coincided with, on average, larger Limacina individuals. Chemistry samples were collected only in 2017 when the CBS MIA program started again, and really results are similar to previous studies where we observed supersaturated surface water. But aragonite undersaturation occurred in some locations at depths greater than 150 meters. But really overall at this point in time, average conditions did not indicate a strongly corrosive water column when we were sampling. But when we look at the shell, the presence of corrosive conditions is very evident. The dissolution damage was assessed according to a scale developed by Nina and co-authors, with type 3 being the most severe measure of damage, indicating compromised shell integrity and extreme frailness. And over 85% of the Limacina assessed had this type 3 damage. This severe damage was observed at every single station in both 2014 and 2017. There was no significant difference between years or habitat. It was just pretty bad everywhere. So now some damage was observed on the growing edge, but the majority of the dissolution was found on the first whorl of the shell, indicating that damage likely occurred during the larval stage of growth, which would have been in May or early June when sea ice was still present. And comparing our to other studies, Nina led this, we found that the occurrence of damage in Amundsen Gulf was higher or more of the population effect than the Gulf of Alaska or mid-shelf of the Bering Sea. One slightly positive observation, and I believe this is a first for samples collected from a natural environment, is that a few adult individuals displayed some evidence of shell repair in 2014 when phytoplankton was abundant. There was patches on the shell where a new organic layer had been deposited. So it's evident that some individuals will allocate resources to repair when conditions allow for it. Concluding thoughts, we don't know the state of pteropods from long ago or even recent trends, but we expect that dissolution would be augmented as acidification has been enhanced over the past couple decades. Sea ice is the key driver for Arctic marine ecosystem functioning, and sea ice likely affected the observed interannual variability in Limacina abundance. However, the severity of dissolution seems to persist independent of differing sea ice dynamics. Within the Amundsen Gulf, the Pacific halocline is a dominant component of the water column habitat, and even deeper water can be undersaturated. So consequently, Limacina and the Amundsen Gulf are living in largely corrosive conditions and may be functioning near their tolerance levels to the point that it may be advantageous or even necessary to invest in shell repair. So if this is true, and if they are functioning near the limits, this could be an issue given that we expect both the magnitude and duration of exposure to corrosive conditions to increase in coming years. And the Canadian Beaufort Shelf and Amundsen Gulf remain vulnerable to ongoing increased acidification of Pacific winter water and potential undersaturation of surface waters. So considering Limacina as an indicator of biological impacts of OA, this study provides a warning or perhaps a strong encouragement that other vulnerable species or life stages, for example, larval Arctic cod, should be assessed and monitored to really understand the possible range of ecosystem responses to ongoing acidification. Turn it back to Mike.
Hi, Andrea. Thank you so much for that presentation. And it looks like the two other speakers that we were expecting for this session, unfortunately, are unable to join us, which means we now are going to move into our question and answer session. So before we get started, I want to ask the audience members to type any of their questions into the questions box, or you could pose your questions on Twitter using the hashtag OAWeek 2020 or the hashtag Arctic OA Hub, and you could @GOA-ON. Additionally, make sure to call out which speaker you want the question posed to, or if it's a general question, just mention that. Any question that we don't get to today will be posted on the Ocean Acidification Information Exchange. If you're not a member of that site, I really would encourage you to do so. It's a great it's a great platform for OA researchers, stakeholders, policymakers to collaborate and share the latest information. I also want to give a short plug to some of the other sessions that will be hosted today. The OA Africa Hub session will begin in 3 hours, or maybe a little less than that. And then later today, there will be the Latin American Hub session. So if the speakers would like to turn on their cameras, I see they've already done that. That's great. I will begin reading some questions. The first one is kind of directed towards Melissa and Agneta. So in a couple other presentations we've seen during OA Week, we saw that ferries could be used to collect data points. So if those ferries are outfitted with sensors, while they're going back and forth between locations, they could collect data. I understand that Norway uses ferries quite a bit for traveling around the coast. I've done that myself personally. So I was wondering if there's any thought about using ferries in Norway to collect kind of subpolar data.
You want me to answer, Agneta, or? Yeah, I can start maybe. Yes, I didn't show as clearly perhaps on this slide for the Norwegian National Monitoring Program, but we are using ferries already with a ferry box system, and some of the ferries have a more advanced PCO2 sensor on board, like the general Oceanic system, and some of them has a little bit of a, I wouldn't say simpler, but a less advanced sensor. So, or more sensor type instead of instruments. But most of them have general Oceanic system, and also on the Hurtigruten from Bergen to Kirkenes, it's been for many years. And also between Oslo and Kiel on that ferry. So, and also the session I showed from Tromsø to Longyearbyen is a transport freighter. And there you also have a general Oceanic system on board. So for sure, yes. They are there.
That's excellent. A question I have specifically for Andrea is something that you kind of mentioned towards the end of your talk about other indicator species besides pteropods. You mentioned Arctic cod. I was wondering if there's any other species in the region that you think researchers should be paying attention to, and then maybe are there kind of economically important species, particularly for the First Nations people that live in the polar region of Canada?
Yeah, I think the key species to look at would be Arctic cods, given that they are so central to the food web, and specifically for the subsistence species. So the key species of concern to the community would include the bowhead and the beluga. And so the beluga has a tight connection with the Arctic cod, as well as many coastal fish species. So I didn't show it in this presentation, but we've started to look at the stomach contents of coastal fishes that the community members are catching, and looking at specifically pteropods in the stomach content, to see if there's a direct link between pteropods and these coastal fish. And in some stomachs, there's a lot, and others there's not. So we'll continue to look at that for a direct link to the coastal species. But really, for species of concern to the communities, it'll be a food web connection. So Arctic cod would be a key one. And you'd have to look more if there's a specific clam or mussel species, but they're not at the top of the list for the communities right now.
Thank you for that. So another question that came in is from Kinshore Budhu. And the question is, the sensor being used in the Arctic, are these applicable to warmer oceans? Or does the sensor have to be specifically tailored to cold water? It's not directed towards anyone, so if anyone wants to jump in, that'd be great.
So.
I mean, yeah, I can answer quickly on this question. And I mean, there are several of these CO2 sensors, and they work differently. But of course, you can use them in warm waters as well. It's more the question, if you go to cold water, you have to adapt, and you have to sometimes have some, if you use dye, for example, you have to have antifreeze, or if you have the cold conditions, you need more batteries capacity, because some of them really need lots of capacity. So it depends on what kind of sensor, because we have in one of our projects, we use different sensors, and there have been some comparisons. But no, the short question is that you can use them in warm water. Do you have something, Melissa, that you want to add on that as well?
No, I can only add that it depends a lot on the sensor type, how the detection is made, what type of battery capacity you need. So it's, but it's a little bit more energy demanding in the cold water.
That's great, thank you. Our next question is for Melissa, and it comes from Maria Grigoritou. And she said, Dear Melissa, I really enjoyed your presentation. Thank you very much. I was wondering if you could say more regarding your forams, and if you noticed any changes in their shell thickness or size.
Oh, that was a tricky question, since that is a collaboration with the UIT and the CAGE project, so Tine Rasmussen and Kasia Kamelchik, and I can give you information where you can reach out to those. But there is actually a recent paper which I'm co-author on by Siri Ofsta, who was a PhD student, and so there is a paper on forams in the Barents Sea. So there are more information on that, but I don't know the specifics for that. But please contact me, and then I can forward the information to you.
Absolutely, yeah, definitely contact Melissa. That's one of the benefits that we're hoping to get from Ocean Acidification Week, is building these collaborations across the world. Another question for Melissa, actually, from Kumiko Scott. It says, Hi, Melissa, great talk. I wonder if the decrease of pH in the Arctic outflow is mainly due to freshwater increase or river ice meltwater ratio changing or uptake of atmospheric carbon dioxide.
It's also a very good question. So I think it's a combination of these things, because since it's such a drastic decrease in pH of what we see now for this period is 0.012. I think it's a combination of anthropogenic CO2 uptake, but I actually believe it's has more to do with the fresh water and the river the river water transported in the transpolar drift. But it can also be a signal from the increased permafrost thawing from the Siberian shelves, bringing more CO2, organic matter, respired CO2. So that's I'm working on that now, and I hope to publish this paper this year and know more about those questions then.
That's excellent. Andrea, this question is for you, and it comes from Libby Jewett. She asks, is the DFO doing any experimental research on pteropods to determine how shell dissolution might affect their populations?
Yeah, that would be great to do. So we're not currently doing any experimental work on Arctic pteropods. It's a challenge to work with them where we're at sea or in a northern location, but it's something we would really like to do. And the other challenge, if we bring them back south, is trying to keep them alive. So there's, as far as I know right now, not really anything experimental work being done on Arctic specific species, but DFO is working on other experimental work on the other coasts, and some work is starting to be done on Arctic cod that have been successfully reared, and experimental work going on the West Coast labs, and other species like lobster on the East Coast. So yeah, we do need to move the pteropod work forward with respect to experimental work.
Great, thank you so much. This next question comes from Kumiko as well, and it's directed towards Agneta. She was wondering if there's any work being done in Greenland, particularly with local communities. She calls out the United States working with Native communities in Alaska, and Canada working with First Nations people up in the Arctic.
I'm not sure. There may be some work doing in Disco Bay in Greenland with local people for the Denmark. Some University of Aarhus, perhaps. I'm not aware of it, but that's something that we should absolutely figure out, and maybe we can start to do something there. And that would be interesting to connect to the Greenland part as well.
I know Greenland. I know Greenland is a big white spot on our GOA-ON map. So at this point, there's no GOA-ON members who are from Greenland, I think. So that might be a place we need to target. So one question that I think everyone in the OA community has right now is how COVID-19 has influenced your ability to conduct research, particularly in a really remote region like the Arctic. And this is a question posed towards everyone. So Agneta, do you want to start off, and then maybe we could go around?
You could repeat the question. I didn't hear it.
I'm sorry. How has the pandemic influenced your ability to conduct research in the Arctic?
Oh, yeah. It has been cancellations of several cruises and fieldwork. For example, I planned fieldwork in Svalbard. I had to cancel because we had to be in quarantine for 2 weeks, and it was difficult for us, but we have help from station people. For example, at Norwegian Polar Institute, we have people up there, so they help with sampling. We also have cruise actually going on right now in the Fram Strait, these annual cruises, but we have restrictions on how many people we could be on board, and only people from Norway could join, and so there were lots of restrictions going on the ship. So yeah, there have been some, especially related to fieldwork, and of course meetings. We have lots of digital meetings, but that works quite well. But sometimes you need to meet in person. But yeah, it's mostly fieldwork. Yeah.
Melissa, do you have anything to add?
Yeah, I can also, I mean, as Agneta says, lots of the field work has been postponed to the next year. So now we are really more or less fearing all the cruises we are going to be on board on next year. And I can't really see how we can do all cruises next year that were postponed this year. But what has implications also for PhD students and postdocs that are part of, for example, the huge Nansen Legacy program, which are really depending on, for example, have a seasonal time series during the same year. And that is, of course, not possible because we started last year doing this seasonal study. So it's there are many implications also for the research ending. And then also we have had experiments that have been also cancelled because we have guest researchers from other countries that couldn't join in coming to Norway. So no, it's been a lot of complications, and I don't think that we can catch up everything next year.
Andrea, anything to add?
Yeah, it's been a year of a lot of postponements, especially for the offshore work, but the work that has gone ahead has really been based on collaboration and people helping each other out. So that's been important. And the northern communities are very, very careful, and the borders have remained closed for going north. So we have not gone north to work in the communities, and even realizing for offshore projects, these communities as an emergency, backup, that's not an option. But we are able to do some mooring recovery, and the community-based or community-led programs have continued in some capacity, which is great, and local staff that are in the north. So there are some projects that are being delivered by those who are in the communities themselves, as well as through other collaborations. But yeah, next year's going to be busy.
Yeah, I think we all agree next year is going to be quite busy. All right, so the last question I would like to pose to our panel is about raising awareness to ocean acidification. How aware are the communities in the circumpolar region to the OA that's happening there? And then what could people do? Agneta, you mentioned Shell Day as a way of raising awareness. And I think as we think about our next session at the equator, the Africa session, what can people at the lower latitudes do to raise awareness of OA happening in the Arctic and around the world in their own communities?
I can start. Yeah, I would say the communities are aware of ocean acidification, and there is the ongoing need to discuss what that means, so that you don't put your hand in the water and your hand gets damaged. So you don't want it to turn into an issue of fear, but to provide the proper information about it. And they certainly understand that with all the other issues going on, that this is another layer, a cumulative effect, and they want to know about what's going on. So there's definitely an interest, and through ongoing communication and presentation. So the projects that I mentioned that the pteropod work came from, those projects only went ahead because we co-developed the projects and had the support of the Inuvialuit. So we will be reporting directly back and sharing and talking about these results. And I know there's work being established that Kumiko's doing for the communities to directly collect chemistry samples, and there's programs like the CROW program in the north that go out and do winter sampling or collecting DICTA samples. So more hands-on work when communities are going out for their traditional travels to integrate that sampling into their work. So, and to work with other scientists as well. So I think a combination of keeping the dialogue open and working with them and putting it hands-on is really useful.
Yeah, I agree with that. I think that's a really good thing to go out yourself, and you know how it is, and then you also easier to understand what's going on. And that could also be something you could add into schools in like low latitudes, as you said, Africa or other countries has to be aware of the Arctic. I mean, it's not so easy for them to be aware of the Arctic when you're in Africa, but I mean, if you maybe you can do similar things, and you can inform them in school, maybe visit schools. Right now it's impossible, but a few years ahead from now, then we could maybe start a small program to visit schools. I think it's to start with the school children. I mean, that's a good thing. And they could do these experiments or collect water.
Absolutely.
Yeah,
Melissa, anything?
I can only add to the others, and I think it's also we have had some interactions with schools in Tromsø, for example, where also they have gone out sampling water samples that we analyze for ocean chemistry, and I think it's also very important, as Andrea said, that to raise the awareness that it's nothing that has happened. It happens, but it's not like it's dangerous. It's not acidic ocean, and in the beginning, I think there were lots of dissolved shells on the science fairs and really scaring people off. So I think it's to have this balanced view, and I think that is much easier if you have a direct communication with them. So, and this type of toolbox, easy things that you can use, probes to measure, would also be great. Now I see where you are.
Thank you. Thank you very much. So it looks like one of our other presenters has joined us, Wei-Jun Kai. And it's a little unorthodox, but I think what we'll do is maybe we'll let Wei-Jun give his presentation, and then any questions that get posed to Wei-Jun and all the questions we didn't get to for the other panelists, we'll save those for the Ocean Acidification Exchange. So I'll ask Melissa, Agneta, and Andrea to turn your webcams off. And Wei-Jun, I will make you the presenter. And you could go ahead and start sharing your screen. A box will pop up that will allow you to share your screen. We're starting to see your screen, Wei-Jun. Go ahead and make the PowerPoint full screen. And then you'll also want to unmute yourself.
All right, so you can hear me now, right?
We can hear you, and we could see the presentation. You could get started. Thank you.
Okay. Well, first I want to apologize for I didn't see that specific link, and I should have followed up last night. Anyway, thank you for this opportunity. I would like to talk about 10 minutes, right? Yeah. Okay. About sea surface, sea ice loss, how that amplifies the summertime decadal CO2 increase, and how this affects ocean acidification in the West Arctic Ocean. And we've been working on this data from 1994 to 2010. This is largely based on a recent the June 15 Nature Climate Change research paper authored by my student. So our research, I'm sorry, goes largely based on this. I'm using another slide. So this is the Chinese Arctic cruise track, shows going through the Bering Sea and all the way to the northern area. Let me see if I could open this point with pen. Yeah. Oh. Zoom in point with laser. With light. Yeah. Okay. Again with laser point. Okay. Good. So this was my first cruise in 2008. So before that, people thought once you get into the Arctic Ocean, it may become very low CO2 because the early work like this one, 1994, 1999 research. For example, shows under ice, PCO2 was very low. The AOS 94 data and the 1999 of this is underway CO2. They're all very low. But my research, I try to shrink this my own view. Why I can't do that? Okay. All right, just block one end. That's okay. I'll let it. So when we get there, the underway PCO2 in the Canada Basin was very high, close to atmospheric CO2. In the Chierici Sea, it's very low. It's always low, and so that was 10 years ago. And then over the last 10 years, we have lots of clues added to this, and that include, this is a summary of all data from in the Western Canada Basin, 94 to 98, 99, 2000. But of course, during the early years, there's no data in ice-covered area, right? Then in the 2008, this was a cruise. You see high CO2 in the Southern Canada Basin, and then keep going on. This is 2012, large area. We have largest area covered with high CO2. And 2014, less, because that year there are more ice coverage, less ice melt. And 2016, 17, and we also add 18. So you see this very large grid. You see this very, let me remove that thing to covers. Okay, so you see this pattern of last 10 years with very high PCO2 in the Southern Canada Basin, basically, and very low CO2 in the Chierici Sea. And so we try to use this data to derive a trend of sea surface PCO2 change. So we came up with this from 94 all the way to current to 2018. We actually upgraded that all the way to the 18 towards the end. And you see a very high, rapid CO2 increase in the Canada Basin, twice of the rate increase in the atmosphere, which is about 1.9 ppm microatmosphere per year. And in the Canada Basin, it's 4.6. That when I list PCO2, basically it's the same. You can get an ocean acidification rate would be also nearly actually twice of the prediction from atmospheric CO2 increase. However, in the Chierici Sea, the CO2 increase is almost zero, and you see large uncertainty. Of course, the p-value is not significant, but in the Canada Basin, it's really very strong increase with significant p-value. And in the other area, like in the northern ice-covered area, actually the increase rate is almost the same as atmospheric CO2, and you can see the more detail in this paper just published June 15 in Nature Climate Change. So that's Canada Basin and Chierici Sea. So we try to explain what happens is this. In the Chierici Sea, it's a high biological production that hold CO2 very low, and the atmospheric CO2 increase that is counter-reacted with increase in biological production. So the PCO2 is low and stable, not increasing. But in the Canada Basin, it is very low biological production, so it is acid CO2 exchange drives this very rapid CO2 increase and rapid acidification. And there's another thing we looked at is this one, it's a dilution of the water, the alkalinity decreased by the ice meltwater that decreased the buffer capacity. So from this value in the 1990s to the 2000s, you are actually you weakening the buffer capacity of the water. So when CO2 absorbed from atmosphere, it actually, the dilution by meltwater and the CO2 uptake, these two factors greatly weaken the CO2 buffer capacity. So you have this very large increase over summer from later spring to the later summer. So the PCO2 increases, this amplify, this seasonality amplified, and over a decade time, you're increasing from here to here. So the PCO2 increase rate is twice of the you would predict from atmospheric CO2 increase. That is the mechanism behind that. And the same goes with acidification that we publish in an early time. So again, this map goes when the Pacific water comes in, it goes to Canada direction and this to Russia direction, and the water actually subducted into into Canada Basin. So this very high biological production water doesn't affect the surface in the Canada Basin. It is subducted into under that. So that this Canada Basin water is separated from the history of this high biological production water in the margin, ocean margin, and it is affected by the Beaufort Dry, and with ice melt really make that water with low buffer capacity and high PCO2. So I use the same mechanism to explain the acidification. This is another paper we published 3 years ago in Nature Climate Change with this very large acidification. So blue color is acidified area, and this acidification expand in both two transect in the Canada Basin. You can see along the 170 line, the acidification area expand to north and deeper depths. And in the 145, 150 line, the same goes with that. So that is what we observed in the last 2 decades. As a result of sea ice melt, you get a very strong increase of PCO2. The rate is twice in the Canada Basin. And you also see the acidification area move to north and to deep depths. So that is my presentation. And lastly, I just want to mention this summer, my group couldn't go to the Arctic Ocean due to COVID-19, but our collaborators from China and Japan are collecting sample for us. So the Chinese crews basically only collect sample in the northern area in the basin, and the Japanese crews are collecting in Chierici Sea. So we hope to do more measurement, and this time we are going to measure carbon-13, see how use that to reflect the changes in the carbonate chemistry. So that's my presentation. Thank you.
Thank you so much, Wei-Jun. I don't see any questions for you at this time. I will take over as presenter. And I just wanted to say that if anyone does have questions for Wei-Jun, please type them into the questions box now. You also can pose them on Twitter using the hashtag OA Week 2020 or hashtag Arctic Hub, or Arctic OA Hub, that is. Any question that we didn't get to for the other panelists, we will be saving and moving over to the Ocean Acidification Information Exchange. And one last time, I wanted to plug a couple other sessions that will be happening for Ocean Acidification Week. We will be having our next session in just a couple hours. That will be the OA Africa Hub session. And then later today, there will be the Latin American and Caribbean Hub session. Tomorrow, there will be talks from the Northeast Atlantic and Northern Europe, as well as sessions from partner and friend organizations of GOA-ON, as well as the capstone presentation. And at this time, I want to thank all of our speakers for joining us today and for giving wonderful presentations. Thank you to the audience for joining us for the 4th session of Ocean Acidification Week, and continue the conversation online, and we'll see you all in a couple hours for the next session. Thank you so much.